going to do the world's fastest recording. So here we go. I wish I'd had more time. Please provide these questions in advance next time, not at the last minute. That way I can make a video that you can review during the week instead of the night before. Cramming never works. Period. Our first step here is to put down the CAS system. We put down the quadrants and we write down the CAS system. The CAS system always starts in quadrant 4, goes up to quadrant 1, over to quadrant 2, and down to quadrant 3. That means those symbols are positive in those quadrants, with this exception being all of them positive in this quadrant. Our next step is finding 315. So there's 90, 180, 270. How much more is 270 to 315? It's 45 more. The big thing here is finding this angle right here, called the acute angle, not this terminal. This terminal just tells us where we end up. We end up at 315. A full angle, a full circle, is 360. So to find this acute angle, it's 360 minus 315, which is 45. Next, we have to realize only cosine is positive here. So our answer will always be in the negative. Notice they want the exact value. That means we don't use a calculator. We have to use our exact value chart that we got from our triangles. Now, here's the hint. Once you find your exact values, you can just write them down on a table. Much like the table you were filling out earlier. And if we look up the sine, because this is still sine, of 45, we discovered square root 2 over 2. So that would normally be our answer, square root of 2 over 2. Except because we're in quadrant 4, where only C is positive, we have to make sure to put that negative in front of this, like that. And that's our answer. Now, sure enough, if I were to take square root of 2 over and divide it by 2, this is what I would get. And so it should be negative 0.0707. Remember that 707. So now if I take the actual value, 315, and find the sine of it, I should get negative 0.707. And that's what I get. This is just the numeric value of this. This is an exact value. Anytime you reduce something to decimals, it is no longer exact. That's why mathematicians always prefer the exact. That's how you do it with each of these. So I'm going to speed race through the next ones. Tan 110. Our first step is to find out which quadrant 110 is in. So we're going to just get rid of all this again. Then we start at the beginning. Okay, so the first quadrant is 90 degrees. And then clearly 110 is somewhere over here between 90 and 180. 90, 20 more is 110. So the question is, what's this acute angle? That's always the question. Well, that's going to be 180 minus the 110, which is 70. That's an interesting angle. 110, 70. Why did they do that? In which quadrant the terminal arm of the principal angle lays the value of the related acute angle. And the sine of the ratio. Okay, so they don't really want anything more than that. So 90 plus 20 is 110. The remaining angle is 70. We do not have an acute or an exact value for 70, so we would not give it. They just want where the principal angle lies, the value of the related acute angle, which is 70, and the sine of the ratio. Well, tan, this is the only thing that's positive in this area, is sine. So the answer is it's going to be negative. It looks like they don't want the value at all, even though I did find the value over here. Let's do the next one, 265. Well, that's 90, that's 180, that's 270. 265 is clearly 15 more. That means this remaining is 360 minus 285, which is 75, and we don't have an exact value for 75, but that's where the terminal arm lies in quadrant 4. That's the acute angle, 75, and they want cosine, and cosine is the only thing that's positive in here, so the result will be positive, and that's all they want. And then for tan 225, we go here to 180, 180 to 270, so 225 is here. And if I look at how much far past 180 it went, so it's 225 minus 180, it's 45. So we can actually find the exact value of this. Notice they want tan, and in this quadrant, tan is positive. So all we do is we find tan of 45. This is tan over here, by the way, tan. I'm going to keep my exact value chart around, which is 1. So the answer to this will be tan of this is equal to positive 1 because it's in a quadrant where tan is positive. And sure enough, if you took your calculator, you put 225 and you hit 10, you'd get the answer 1. All right, next question. This is a lot easier if you use a graphing tool or graph paper. Whenever something asks you to plot something, it's smarter to use graph paper because then you will get a visual accuracy. But I'm going to do the next best thing. I'm going to use Desmos. So let's look at our first point, 511. Here we go. Desmos, where are you, 511? Let's light up 511. Unlabel the other ones. 511. There you are. It's right up there. Each block right now is 1, or big square is 1. Take a picture of it. Put it over here. Include origin. So our first step is going to be to draw. Now keep in mind this is not a unit circle anymore because it's clearly bigger than 1. But my first step is going to be draw a line straight to origin. Let's make it red. That's going to be my hypotenuse. My next step will make my y values green. So I'm going to draw a line straight down here. Here, like that. And this clear has the same height as my y value, which I can see is 511. 511. So that means my height here is 11. Then I'm going to use a blue line for my x value, and I'm going to draw it horizontally, and it's clear that this has a length of 5. And the angle you're always looking for is over here at origin. So this is theta. I'm going to call it angle alpha. We'll just call it angle, or I wish I had the theta sign. Theta. We'll just use theta. So that means we don't need our exact values here. We're going to just temporarily get rid of them. I'm going to put them on a different page. Go back to this, get rid of them. That means I go to SOHCAHTOA, and I'm going to assume she only wants the sine, tangent, and whatever. But SOHCAHTOA says the sine is equal to the opposite divided by the hypotenuse. Well, we don't have the hypotenuse. We have to use the Pythagoras theorem, which says a squared plus b squared is equal to my hypotenuse squared. Well, that's going to be a is 5 squared, and b is 11 squared. And that's 25 plus 121, which is 136. It's equal to h squared. So it means h is equal to the square root of 136. But in the question, they actually ask us for the nearest tenth. So we're going to actually take the square root, which is unusual. Normally you don't. And we're going to take the square root of it. And we get that. Now they want it to the nearest tenth. So we have to take 3 digits because the nearest tenth is the second decimal. Oh, wait, that's the tenth. Sorry. So we have to look at the point after that to see if it influences that. If the point is 5 and up, this is rounded up. If the point is 4 and down, this is left at 6. But the number after it is a 6. So this gets rounded up to 6. So that means my hypotenuse is actually 11.7. And it should have been in red, but that's okay. That means you now have your opposite. We can label them all if we want to be efficient. My opposite to angle theta is 11. My adjacent is 5. My hypotenuse is 11.7. So we can now use SOHCAHTOA. That means the sine is equal to the opposite, 11 over 12, 11.7. And it means the cosine of theta, you have to have theta up here as well, is equal to the adjacent. That's ka over hypotenuse, which is 5 over 11.7. And my tangent of theta is equal to the opposite, toa, over the adjacent. That makes 11 over 5. Now, there's 3 other trig symbols. Cosecant is the flip of theta, of sine, so you just flip the fraction. Secant is the flip of cosine. I don't know if she's assigned these yet, so you just flip the fraction. And finally, tangent of theta, or cotangent rather, is simply the flip of the tan up above. So cotangent's that. I don't know if she taught you that. I'm probably going to skip that for the rest of them, but that's how you do the 3 other ones. Then they want you to calculate the value of arcsine. Well, you only need one of these to do it. They want you to calculate the angle to the nearest degree. So that means we have to take 11 and divide it by 11.7. And we get this. Include as many decimals as possible for now. So that means sine of theta is actually equal to this. To get rid of the word sine, we have to take the arcsine of both sides. Well, arcsine is the opposite of sine. It essentially cancels it out. That's when you want to get rid of the word sine, which means the angle theta is equal to the arcsine of this number. So I just take that number and press arcsine, second degree, sine to the -1. I get that. And that means to the nearest degree would be to here. We have to look at the degree after. There's nothing that it's below 4 and below. So we're talking about 70 degrees. Now what's interesting is no matter which one I took, so I can take this one, (2.2). Tan is the only one that can be above 1. So if I take the arctan of both sides, it cancels out this tan, and angle theta is equal to the arctan of 2.2. But what's interesting is it'll give me the same angle. Oh, it didn't. So I did something wrong the first one. So I got to go back to do the first one. It's 11 over 11.7. So let's do that. 11 divided by 11.7. Good thing I did a second one. So it did. So that's what I get. And then I take the arc sine of it. Arc sine. And I get that. No, I still got that. So why is it giving me opposite over hypotenuse? It's 11 over that. Tan should still give me, oh, I did the wrong one. It's 11. No, I didn't. So let me do arctan. It's giving me the wrong one. So I'm wondering if I did the hypotenuse wrong. I probably did the hypotenuse wrong. So it's 11 squared plus 25. I did do the hypotenuse wrong. It's more than 12. 12.08, so 12.1. So this is not correct, so that doesn't help. It's actually 12.1. It's actually 12.08. And I got to round up to the 10th decimal, which is here. Since that's an 8, it becomes 12.1. And that makes all these values that I've calculated up above incorrect. So I should have checked my, should have known that was off. So that means this is this, and this is this, and that one's right. So now we got to do this instead. And it means this decimal is wrong. So we're going to take 11 over 12.1. And we get that, 0.9090909. And then we're going to take the arc sine of both sides. There we go. That's the angle I'm supposed to get. And now I got to round up to this degree. This one's below 4 and below, so it's 65 degrees. And it doesn't matter which one I took. And notice when I took tan, I corrected myself because I figured out the correct one. Now, what about, it's important that I do one more. I want you to do the other two, but they're all done the same way. But I'm going to show you one that's in another quadrant. The next one is over here. This one's nice. Quadrant one's nice because they're always positive. But this one is not going to be, all the values are not going to be positive. As a matter of fact, only sine is going to be positive according to SOHCAHTOA. But we're going to do the same method. We're going to take our graph. We're going to try it again. We're going to maybe pull it down a bit. There we go. We do this. I'm going to get rid of the other one. And at the dot, we're going to draw a straight line to origin. We'll make it in red to make sure our hypotenuse is there. Close. Close enough. And then I'm going to draw a green line straight down for my y. And notice my y is the same as the y up above. It's going to be 3. But here's the interesting part. Technically, my x is not 8. It is 8 long. Spatially, it's 8. But it's really in the -8 zone. And here's why you'll see now why some things are negative and some things are valuable. Sorry, positive. And we're ultimately looking for this angle over here, which is at the origin, theta. So now we've got to figure out the 3 things about theta, but one of the most important things we can figure out now is the hypotenuse. And hypotenuse is going to be this squared plus that squared. It's square rooted. So I get 9 plus 64, which is 73. So that means the hypotenuse is the square root of 73, and they want it to the 10th decimal, but just to 1 decimal. 73 square rooted is that 85.54. H is equal to 85.54. And that means I got to look to this second number to see if the 5 changes. This is 4 and below, so the 5 just changes the same, stays the same, which means my hypotenuse is 8.5. Now that I have the 3 values, I'm just going to do sine, cosine, and tangent. Sine is equal to the opposite over hypotenuse. Well, the opposite to theta is 3 over the hypotenuse of 8.5. Cos of theta, angle theta, I should have had angle theta up here too, is equal to adjacent. Now, let's keep that -8 in there over the hypotenuse, positive 8.5. Hypotenuse is always positive. And tangent of theta is equal to the opposite over the adjacent. So that's going to be 3 over -8, which is the same as -3 over 8. You usually put the negative at the top. Notice that my sine is the only thing that came out positive. My cosine came out negative, because -8 divided by positive 8.5 will be negative. And this will also be negative, which is why in the CAS system, only sine is positive here. It's because hypotenuse and opposite are positive in this quadrant. Well, then we just got to figure out, they want it figured out. So now we can use any one of these. If they want the decimals, I can't remember if they wanted the decimals. Let's have a look. Determine the value of r to the nearest tenth. We did. Determine the primary trig ratios. We did. We can convert them to non-fractions and calculate theta. Well, if they want the decimals, you'd have to do 3 divided by 8.5. You'd get this. But really, the fractions are nicer. Here you'd have to take -8 and divide it by 8.5. And you get this. And 10, you'd get -3 over 8. And you get this. Notice cosine, tan are negative and sine is positive. You can take any one of these to figure it out. So sine theta is equal to 3 over 8.5. And technically, I'd always want to be using tan theta to solve it because I didn't have to round up any numbers there. It's Dave, Mom. Yeah. So let's use tan this time. Is equal to 3. Is equal to 3 minus 3 over 8, which is equal to negative 0.375 because it's a nice number. So to get rid of tan, I have to take the arctan of both sides. So that means theta, angle theta, is going to be the arctan of negative 0.375. So we'll just take the arctan of that, and it'll give us the angle. Tan to the -1 is arctan. And this is the angle. Now, notice they don't give us the right angle. I should have used my sine because my sine is positive. They've given me an angle over here. That's because that's the nearest 10 that's negative, which still means that this angle is 20.55. So let's use the positive one. Let's use the positive one. Let's use 3 over 8.5. We'll do the arc sine of that. And we get 20.66, so we get the positive version here. Probably smarter to use the positive, whatever thing is positive. So that means that thing is this, but they want it to the nearest degree. This is a 5 and above, so it's 21 degrees. That's theta. How do you do the other ones? Same way. So I'm not going to do the other ones. I'm going to label them, though. This one, draw a straight line to origin. Then draw a straight line to x-axis, not the y-axis, always the x-axis. And then here, so this length here will be -5, and this depth here will be -8, which means your tangent will be positive. So use your tangent value, arctan, to figure out the angle. And then you also have to figure out hypotenuse. Again, it's 8 squared plus 5 squared, 64 plus 25, which is 99, square root of 99. Then this one, draw a straight line. This one will have exact values, actually. It'll be an exact, it looks like it's going to come out as like 60 degrees. So you draw a straight line there, and then straight line to the x-axis, straight line this way. So this x value is going to be 6, positive 6. The y value is going to be -8. Square them and add them together. You get 36 plus 6400, which means your hypotenuse is an even 10. So that means sine of this is going to be the opposite, -8. Let's use what's positive here, cosine. So cosine is going to be the adjacent, which is 6 divided by 10. So 6 divided by 10, 0.6. And then we take the arc cosine. And we discover the angle 53.13, or 53 degrees. So it wasn't quite pure. But that'll be the angle there. So do them all. The angle for this one should be, we'll just, in this quadrant, it's tangent. So we'll do opposite. It's going to be 8 over 5. So we're just going to do 8 over 5 and arctan. Your angle here should be 57.99 or 58 degrees to the nearest degree. There you go. That's how you do that one. I don't know if I'll be able to do all these questions. Please provide me with the questions well in advance so that I can do a video. I definitely will not be able to do all these. How do you do number 9? Let's look at it. You're probably going to have to do arctan in this thing. So this is all the degrees. Now, in 360, there's always 2 of these. So let's figure out where they are. In quadrant, this is a positive value. So where's cosine positive? Here and here. So your calculator will always spit out quadrant 1. So we have to take the arc cosine of this to figure out the angle. And they want the angle. They didn't really tell me what exact angle. So let's just do that. So I have to take the arc cosine of 0.6951. And we discover that this degree here, well, not that one. We have to do the second, cos -1. We discover the degree is this, 45.96. Now, clearly that angle is here in quadrant 1, there. But this other quadrant has the other degree, which will also form the same acute angle to the x-axis. It's always to the x-axis, right here. But they never want the acute angle except in quadrant 1. They want the principal. And the principal, in blue, is an angle that starts here and goes all the way over there. So you have to take 360 minus that to find the principal angle. So I'm just going to subtract 360 and then make it positive. It's the same thing. Make it positive. So the actual angle they're looking for over there is the second angle, is this. And you do that the same method using CAS for all of them. Okay, so this one here, tangent. And this is negative. In what quadrants? There's always 2. Will tangent be negative? The only ones that will produce one result are 90 degrees, 180 degrees, and 270. 360 and 0 degrees will produce 2 results because they both have the same value right here of 1, 0. That's the cosine of 360 and of 0 degrees, and 0 is the sine of 360 and 0 degrees. But where's tan negative? Well, C-A-S-T. Tan is negative here and here. Our calculator is going to spit out the nearest one to the x-axis, so it's going to give us a negative angle here. So I have to take the arctan of negative 0.7571. So this is our angle. Oh, I'm going to do that again because I forgot to make it negative. So this is our angle. And it's given us a negative angle. So it's given us this weird angle down here. Get rid of all my sketchiness. But that angle is not an angle we would use. Negative 3.7 is going in this direction. We want this angle, which is 360 minus that acute angle, 37.129. 360 minus 37.129. And you can use the other decimal. So that first angle is actually this one. This is the first actual principal angle that they're looking for. But tan is also negative over here. So we have to put the acute angle here, 37.129. And we have to find this principal angle to there, which is 180 minus that. So this is the second angle, 142. So you're going to get essentially 322.871, whatever it was, and 142.87. Okay, now what about sine? Where's sine positive? So I'm not going to do the rest of them. So sine is positive here, according to cast, and here, which means when I take arc sine of that, it's going to be the acute angle here. Then you have to take that same acute angle here, take 180 minus that acute angle to get the second degree. Where's cosine negative? Cosine is negative here and here. My calculator is probably going to spit out this one because that's the closest one. Oh, actually, no, it might spit out that one. So let's find the arc cos of that and see what we get. 0.2882 negative. It's telling me it's 106 degrees. So that's great because it gives me the first angle quite easily. 106 degrees is my first terminal angle. But that's a pain in the butt because I need to figure out the acute angle here, which is roughly 73.3. And I have to figure out where cosine is negative again, which is down here. So I have to do the angle 73.7 roughly. No, 73.25 roughly. And I have to add 180 to it. So the other one we're talking about is 253.25 degrees. So we're talking about 106.7502 and 253.25 something. So the acute angle is absolutely necessary to figure out the two angles. And unfortunately, sometimes if it spits out here, you have to figure out the acute angle. Whereas tan positive here and here. So your first value is going to be here. Then you got to take 180 and add it to the angle you find. Where's sine negative? Well, sine is going to be negative here and here. So the calculator is going to hit a minus degree here. You're going to have to take 360 and subtract that degree, not the minus version, but the positive version. And then the other places here, you're going to have to take 180 and add that acute angle. Next. Paintball shot at a wheel of a radius 40. Just to let you know, radius of 40 wheels, the 40 is the radius of the wheels almost always the amplitude of the formula of the curve. Okay. And a paintball shot at a wheel of radius 40. And the paintball leaves a circular mark 10 centimeters from the outer edge of the wheel. As the wheel rolls, the mark moves in a circular motion. So I assume it's going to go in this way. Oh, it's the wheel rolls. I guess the wheel's rolling that way because if it's going this way, the outer edge is going to go that way, which is weird. Assuming the paintball mark starts at its lowest point, so it's down here, lowest point, determine the equation of the sinusoidal function that describes the height of the mark. So if we're starting at the lowest point down here and going up and then back, this is an upside down coast curve again. But beware, I was wrong. This is not our amplitude because the paintball did not hit the outer edge. It hit 10 centimeters from the outer edge. If I take the radius, which is 40, and I see that we're 10 short of the radius, the actual circle that we're measuring is here, 30. Not 40. Just ignore that. We're actually measuring this gray circle. So my amplitude is always almost the radius of the circle, 30. But we can use the lowest part. So here at 10, it's 10 centimeters off the ground, right? 10 centimeters off the ground. And then when I go all the way up here, it's the full 40 to the center plus another 30. The max value is 70. How did I figure that out? Well, from the ground to the center of this wheel is 40, and to this gray area is 30 more, 70. So now we have our max and our min, which means my axis, or my amplitude, is going to be 70 minus 10 divided by 2, which is 60 divided by 2, which is 30. 30 is amplitude, and it's also my A value. My axis is going to be max plus min divided by 2, which is 80. Divided by 2 is 40, which makes sense because the axis of this wheel is 40 centimeters off the ground. Now, remember that it's starting at our lowest point and then going up and then down. So there's no need to shift left and right. However, a coast curve is normally starts at the top and then goes down. They want us to start at the bottom and go up. So we're talking about a negative coast curve. So that means that we have no translation left or right. Now, what about the period? Determine the equation that describes the height of the mark in terms of the distance the wheel travels. In terms of the distance the wheel travels, we have to know when this thing does one full circle. In other words, how long is this outer edge? How long is this outer edge? Or better yet, we actually have to measure the gray circle. How far is this gray perimeter of the circle? Well, perimeter, that would be the period. Well, perimeter is 2 times pi times the radius. Don't use 40 because we're talking about the little gray circle. They really made this question annoyingly hard. Times 30. So it's really 60 pi. Or 60 times pi. So let's find out what 60 times pi is. Oh, that's not 60 times pi. So this is how my actual period, it goes around this distance. 2 pi times radius. Oh, it didn't copy. So that's my new period. So my old period was 360, which by the way is 2 pi. And my new period is 6 pi. 60 pi, the pi's cancel. We're actually talking about 1 over 30. Don't ask me how I figured that out. So we can just do it this way if you want. 360, yeah, old degrees divided by new degrees. There we go. We'll do it like that. So we're going to take 360 and divide it by this number. Don't ignore what I'm doing. Just you do it 360 divided by that number, and you should get this value, 1.9. So that's the number I would put in front of it. So now we're going to put it all together. Y is equal to 30 cos. That number, let's just round it up, x, and it's got to be flipped upside down, and my axis is at 40. There you go. The wheel completes 5 revolutions before it stops. Determine the domain and range. Oh my goodness. So it goes 5 times this distance. 5 times 188.4955. So we have to multiply it out. Yeah. We'll just take 0.49. So it travels actually this far. Instead of 1 revolution, it travels this revolution. So it goes from 0 to that distance. Which means my domain goes from 0, smaller or equal to x, smaller or equal to 942.45. That. My range goes from my min, smaller or equal to y, smaller or equal to my max. Well, my min was 10 off the ground, and my max was 70. So that's my range. If the wheel complete, what is the height of the mark of the wheel has traveled 120 millimeters from its initial position? So that you have to use the actual equation that we figured out. So 120 is an x value because x is measuring the distance. So we're going to actually put this in. We want to know how high that mark is when x is 120. So we have to do this. Minus 30 times cos of 1.9 times 120 for x plus 40. You always solve your brackets first. And you always do cos once you have it. We're going to take 1.9 and multiply by 120. And you get 228. So you're going to find the cos of 228 plus 40. Now, cos is considered like a bracket. You do it before any multiplications. So we've got to do 228. Notice that cos should be negative because we're in quadrant 3. Got negative 30 times this value plus 40. So we're going to multiply by negative 30 now. And then we're going to, which we get this. And we got to add 40. Which is 60.073987. Which means if I were to put this on a graph and do this, at the 120 mark on the x-axis, and the max, remember, is 70, and the min is at 10, it hits roughly 60. So it's going to be roughly either up here or over here. It's either on the way up or on the way down, because that's a height of 60 on the y-axis. And it'll happen again because we did 5 revolutions. It's going to happen 1 period later, so plus 188, and 1 period later, plus 188, and 1 period later, plus 188. So this question is actually incredibly complicated. Do they just want the first one? Let's see. The question asks, what does the question ask? Yeah. If the wheel completes 5, what is the height of the mark when the wheels travel 120? So just that's the first one. Using graphing calculate technology, determine x when f of x is equal to 7. Okay. So we have to put this in our Desmos. Fortunately, she doesn't want you to do complex calculations for y, which is good. So we just put that formula into Desmos and ask ourselves, what are they asking? When f of x is equal to 7. Well, they're asking us when the y value is 7, because f of x is over here. And they're telling us that's equal to 7. So they're asking us when the y value is 7. So we do that, and we put it here. So it's quite clear. And we could have figured out the period to figure it out. Oh, actually, I got to put this in degrees. That's the other problem. There we go. And now I got to make it more visible. There we go. That's good. Quite clear that 7 is the max. And we could have figured that out because max is amplitude plus axis. So we could, all we would need to know is the period. The period of this is 180, because if you want to find the period, you take 360 and divide it by the number that's in front of x. 360 not multiplied by 2, remember x lies, divide by 2, the period's 180. So it's going to be at 7 at 0, 180, and 180 later, 360, and 180 later, 540. And then 180 later, 720, and forever. And we would write this like this. We would say it's at 0, f of x is equal to 7. At 0, or when x is equal to 0, plus k times 180, which means forever after 180 more. So first occurs at 0, when x is 0, and then 180 forever after. If she wants the tedious way, you'd say it occurs at 0, 180, 360, etc. And every 180 after. Oh, and by the way, it'd be plus or minus, because you can go backwards too. So if you look at this graph, it occurs over here as we go to the left of the y-axis. So let's find the y-axis. There's the y-axis. It occurs also as we go backwards here at minus 180 and minus 360. So it's plus or minus every 180. Complicated question. Okay, we did this one together. And we did number 5. And now we got to do number 6. If you forget how to do number 5 and whatever, get in touch. And I think number 6 is the last one. Milton. Oh, I've done this one. Milton's floating in a pool. In a wave pool. So let's imagine a wave pool, okay? And usually the bottom of the pools are the x-axis, or the bottom of anything. It's the x-axis. So here he is. There's the bottom of the pool. He's at 1.5 meters from the bottom when he's at the trough. Now, they don't explain trough, but here's a wave. That's the crest. And the bottom part is called the trough. So trough is the min. Crest is the max. So just think of that. So they're telling us the min is equal to 1.5. And then he's at the top of the pool is 2.1. So now this is what they're telling us. The min is 1.5. The max is 2.1. But they also tell us when it occurs. They tell us the min occurs at 0 seconds because they started the stopwatch then. And then the max occurs 1.25 seconds. Now, I don't know if you remember. First of all, if I draw this, here's the min, and it's 1.5 off the bottom of the pool. Well, yeah. And it's going to go up to the max. But that's just half the curve. And they're telling us that lasts 1.25 seconds. But to go back is the second half. And what I told you was the distance along the x-axis between min and max will be half the period. Well, they've told us it goes from 0 to 1.25 seconds. So that means the distance here is 1.25, which means the full period will be 2 times that, which is 2.5 seconds. So now we also know the period. It's twice the distance. It's either the distance between max or min and min, or twice the distance between min and max. So the period we know is equal to 2.5 seconds to go all the way up and down. If we also look at the shape, it's clear, since we start at the bottom again, that we're talking about an upside down coast curve again, because a real coast curve would start here and then go down. So that makes it easier. We're talking about a coast curve. Determine the equation of the function. Well, we have to find the amplitude. Amplitude is max minus min divided by 2. Max is 2.1. The min is 1.5, which is an amplitude, and then we have to divide by 2. So that's 0.6 divided by 2. which is 0.3. So 0.3 meters, or 0.3. Then we have to find the axis. Well, the axis is min plus max divided by 2. That's 1.5 plus 2.1, which is 3.6, divided by 2, 1.8. So the axis is 1.8. So we already have a lot of information. It's y is equal to, upside down makes minus, 0.3 is our amplitude, cos. We need to figure out our period. It's 360 divided by the period we want. Well, the period we've just learned is 2.5. So we're going to take 360 and divide it by 2.5 and see if that comes out as an even number. It doesn't come out as an even number. You have to find a fraction that works. It's 144. Cos 144 x. There's no need to translate x left or right. And then we just throw on the axis. And if you ever want to make sure, you pull up Desmos and you make sure it matches the description of what they've told us. Now, sometimes Desmos will look like this. And you have to remember to go in here and make sure your x shows one period, so from 0 to 2.5, and that your y, and you have to make sure you're on degrees. And then you have to make sure your y shows you the depth of the pool from 0 to 2.1. And this way it gives you a good idea. You can also, so there we go, you can also put in your axis if you want. You can put in your max if you want to make sure you got your max right. Put in your min if you want to make sure you got your min right. And you can see if he hit the max at 0, min at 0 seconds, and the max at 1.25 seconds. And you did. And then you can make sure your period is indeed 2.5 seconds. So there you go. You've matched where he's at the top of the wave and where he is at the bottom. And you have a model of this wave pool. So he goes up and down and up and down. And keep in mind that the bottom of the pool is right here when y is 0. There's the bottom of the pool. So he's floating up here. His little feet are floating right there. So he's never touching the bottom. There you go. That's it.